Hi, everybody. Thanks for coming for this special seminar of the Institute on Ecosystems. It's really great to see all of you here on this particular day. It's a pleasure to introduce Dr. Jerry Elwood, who's had a very distinguished career in the federal government on issues related to climate change and the environment. Jerry served as the director of the Climate Change Research Division in the U.S. Department of Energy under three administrations. He, prior to doing that, he managed DOE's program on ecosystem research and the National Institute for Global Environmental Change, which is an academically based research institute with regional centers that support DOE's mission on climate change. And then earlier, he was a research scientist at Oak Ridge National Lab, a staff scientist for the Federal Committee on Earth and Environmental Science, and program manager for the Office of Science at DOE. And when he was at DOE, he helped conduct and support environmental and ecological research on a variety of topics, things like watershed biogeochemistry and hydrology, nutrient cycling, stream ecology, acid deposition and its effects on surface waters, and radionuclide cycling. So he's covered a great range of topics in his career and helped facilitate research. He's a fellow of the American Association for the Advancement of Science, and he's very active in various professional societies, including AGU. But the most important thing is that Jerry received his Bachelor's of Science from Montana State University, go Cats, in 1963 in Fish and Wildlife. And then he went on to get his PhD at the University of Minnesota in 1968. And he and his wife, Judy, who's also down in Bozeman now, they moved to Kalispell around 2010. So thank you so much for coming. It's great to have you here.
Thank you, Kathy. Well, thanks very much. It's great to be back at my alma mater. I must say I always enjoy visiting here. This is a great place. It's a great university. When I was in school here, it's called Montana State College. So it tells you about how long ago I was here. When I received the invitation to come and give a talk here, I received an email from Jessie asking me if I would provide a title. And in her email, she suggested I provide an interesting title. And I assumed from that she wanted something provocative, something eye-catching. Clearly, this is not provocative. It's not very eye-catching, but I hope it tricks your interest. So I'll get right on with the presentation. Now, climate change is a subject, an environmental issue that has probably had more written about it, more published about it, more assessments of it than any environmental issue in the history of this country. I mean, these assessments have been international, they've been national, they've been regional, they've been local, they've been statewide, they've been sectoral. I mean, there's an assessment on almost every domain of climate change you can think of. This is a statement from a U.S. National Academy of Science report, America's Climate Choices, in 2010. And this assessment of the consensus about climate change has been around for more than a decade. It has not changed much during that decade. And as a result of this consensus, there's been increasing calls in the assessments for actions, more abrupt actions to deal with climate change. And these are two examples in recent reports, a 2011 report and a 2018 report. This last one is from the Intergovernmental Panel on Climate Change. Now, given these calls, the question is, why are we not doing more faster to address this problem, given these calls for abrupt actions? What are the impediments for society, for humans, to do more on this issue, given that we're facing potentially catastrophic changes in climate and the impacts of climate change are already occurring and will only get worse. So first, let's ask the question, why is climate change such a difficult policy problem? First, unlike other issues, it's cumulative. It's a long-term challenge requiring sustained global actions and investments over many decades. We have made the decision in the society around the world that we're going to emit greenhouse gases into a defined resource space that we all share and that protects us, it sustains our climate. But we're going to do this over long term without paying the cost of it, without considering the cost of it. The longer we wait to address this problem, the problem only gets bigger and it gets harder to solve because we're further increasing the concentration of greenhouse gases in the atmosphere. It makes the problem even more difficult to solve. So we're committing the climate to change even more in the future. Every day goes by that we don't reduce greenhouse gas emissions. Now this figure, you've probably all seen this figure. This is a plot of the emissions of the cumulative emissions of CO2 to the atmosphere as a function of the atmospheric concentration of CO2. Now this figure is somewhat dated. Currently, the concentration of CO2 is off this chart. It's 410 parts per million by volume. So the cumulative emissions have caused this to happen. That's why this is such a difficult problem. We have to address this at an international level. This simply can't be avoided. And the reason is that climate stability is a global good. We depend on a stable climate. Modern civilization has thrived when the climate was stable. And when climate is not stable, civilizations have suffered badly. So if we fail to sustain a stable climate, it will be costly for the whole world. And as I said, it's the cumulative global emissions that matter. So we have to look at the cumulative global emissions. Looking at it only from a state or national level won't solve the problem. And this is another problem that we face. The actual cost of preventing or mitigating climate change is concentrated in relatively few high-level greenhouse gas emitters. These are nation states. This figure shows the cumulative CO2 emissions by country since 1751. Now, only 10 developed countries are responsible for 72% of the excess CO2 in the atmosphere today. And you can see that the US is the largest, far and away the largest single contributor. So unless these countries take part in reducing global emissions, the problem will never get solved. Now, we tried one international effort, the Kyoto Protocol. This was a treaty that was signed in 1977. It was an attempted first step at reducing global emissions of greenhouse gases. But in reality, it turned out to be a policy and institutional failure. The treaty was simply inadequate in scope to fulfill its primary mission. That is, it didn't result in the reduction in greenhouse gas emissions. In fact, after the treaty was implemented, global emissions actually increased. They didn't decrease at all. Even full compliance with the treaty would not have reduced emissions. The treaty was designed in a faulty way that essentially doomed the treaty to failure at the outset. There was a bias in the treaty toward short-term commitments that didn't provide any incentive for emitters to reduce over the long term their emissions. And unless you reduce them over the long term so that every country gets to net zero emissions, you will never stabilize the atmospheric concentration of CO2 and therefore never stabilize the climate. The US never signed the treaty and our emissions went up. We withdrew from the treaty because, largely for economic reasons. Now, if we look at the current plans and goals to reduce greenhouse gas emissions and stabilize climate, all of them are not going to get the job done the way they're currently configured. There's no enforcement mechanism in them as they're now configured. There's no incentive for long-term reductions, although that's often a goal, but the specific strategy to get there is not in place. Even full compliance would only reduce the rate of increase, but it would not stabilize the concentration. So greenhouse gas levels would continue to increase, but at a lower rate. Net positive climate forcing would continue to increase, but at a lower rate. And the climate would not be stabilized, but continue to get warmer. And that's a problem with almost all the treaties and action plans that I've looked at. So now let's look at why this is such a difficult policy issue for decision makers to deal with. As I said, it's a global problem. It's the typical tragedy of the commons. It's a conflict between a free finite resource, in this case, the global atmosphere, and the common good, a stable climate. There's no incentive for greenhouse gas emitters to give this up as long as the private benefit to them and their individual interest is positive. If they don't have to pay a cost for this, they're not going to reduce their emissions. So we have to externalize, we've essentially externalized the cost of emitters emitting their greenhouse gases into the atmosphere. Unless we internalize the cost, so they pay the cost of their emissions, they're never going to have an incentive to reduce them. The cause is obviously closely entwined with a lot of important human activities. Diverse emission sources from energy production and use, from the transportation sector, from food production, from industry, from land use changes, you name it. Almost everything we do in society involves directly or indirectly emissions of some greenhouse gases to the atmosphere. The cause is mostly invisible. We don't see the gases that are being emitted to the atmosphere. They're invisible. When you drive down the road and you look at the tailpipe of people's cars, you don't see greenhouse gases, CO2 coming out of the tailpipes. And yet for every gallon of gas you burn in your car, you emit almost 20 pounds of CO2 into the atmosphere. And you think about all the cars on the road, driving day after day, mile after mile, they're all emitting CO2 continuously. And on a cumulative global scale, that's a huge amount of CO2. And this is the biggest problem, I think. Emissions are driven basically by the momentum of our economic system. We have a carbon-based economy. And unless that changes, it's going to be very difficult to solve this problem. Now, to solve this problem is going to require a broad suite of long-term transformative actions, and I'm not sure we're prepared to undergo those transformations. We've got to essentially transform our entire energy system to do away with a carbon-based source of energy for electricity production in this country, and for transportation, and for industry. It will require sacrifices to solve. Some options are likely to increase the cost of energy. Some may cost job losses. It will cost other economic dislocations, and they will unlikely foreclose some choices that we now make. And we need to change the way we evaluate the costs and benefits of what we do. Right now, we largely do cost-benefit ratio based on the monetary cost and the monetary benefits. but we've got to look at things beyond the monetary cost-benefit value. And the issue has been politicized, which creates a problem. I mean, we would hope that on an issue as important as this, that politics would be laid aside and we could come to a consensus on how to solve this problem. But that's not been the case. The fact is that the most influential factor in determining public perceptions and attitudes about climate change is the people's political predisposition and identity. And this has stifled honest and informed debate about what basically the global risks are and what we need to do to solve this problem. And there's always this conflict between the existential and distributional politics. Who gets what and who pays for what? Who pays to remediate CO2 emissions? Who gets the benefit of the remediation? And this is a difficult challenge that we face. If we can't come to agreement about who has to pay some costs and who will benefit and what the benefits and costs are, we'll never solve this problem. How would the cost of economic adjustments required to reduce emissions be distributed? Should climate-forcing asset owners benefit at the expense of climate-vulnerable asset owners? Should developed nations responsible for most greenhouse gas emissions pay developing nations most vulnerable to those emissions, but are least responsible for the costs? Should we pay to help those countries enhance their adaptive capacity and their capacity to resist the adverse consequences? Now, political and governmental short-termism is a common problem in the federal government, and it's a common problem in all governments. When political people are elected for finite terms, and they tend to think only about what they're going to do when they're in office. They don't think in terms of long-term visions and plans required to solve problems that require long-term actions. And this is a huge problem in the federal government. I mean, Congress, for example, is very good at asking agencies, give me a long-term plan to do something. And agencies provide Congress with a long-term plan and a long-term resource need to solve the problem that's been identified. But does Congress appropriate the funds required to solve the problem over the long term? Absolutely not. The plan gets, if it gets read by members of Congress, gets stuck on a shelf, collects dust, and is ignored. They think they've done their job because they forced agencies to do the planning. Planning is the important process. Actually, carrying out the plan is secondary. And that's a problem in government in general. Now, this is a cultural problem. The devotion to the primacy of the individual. You know, how is climate going to affect us? What is it going to cost us if I have to pay more or do something to help mitigate climate? If you can't change that mindset in the culture of thinking of our country, we're not going to solve this problem. And this is another problem. The need for policy decisions in the face of uncertainties and false perceptions about the science and the risks. And when it comes to policy making, all policies are informed by and based in part on scientific findings that are made in the face of uncertainty. I don't care what policy you can think about. There is also always some uncertainty about what the costs are going to be, whether the costs justify the benefits. So saying society should wait until there's no uncertainty before taking action is the same as saying society should never take action. But we don't think about climate change in this sense. The uncertainty issue is always raised whenever you talk to policymakers about what we should do. We never know enough. Tell me more. I don't know enough to justify any action. And you can't convince them to apply the precautionary principle. Whenever it's too risky or too late to wait for information. You have to act in the face of the uncertainty. And most assessments are very conservative. They tend to maximize the risk. That's true. But maximizing the risk is not a reason why you shouldn't take action. So here's some of the public perceptions about science and the risks affecting policymaking. There's false perceptions by the public of scientific controversy. People think there's actually a controversy in the scientific community about whether climate change is real, what its cause is, what the risks are of it continuing, what we're going to do about it. So they assert that there's insufficient evidence to act. They exaggerate the economic costs of mitigation, and they ignore or minimize the economic, environmental, and social benefits of avoiding dangerous anthropogenic interference with the climate system. These are some common arguments made, species arguments made about the cause, consequences, and risks of climate change. These include there's no proof, science is uncertain, there's no consensus, if it's warming, it's all natural, if it's human-induced, it isn't necessarily bad, CO2 is not even a pollutant, so the more CO2, the better. Humans can readily adapt to any changes in climate. And of course, this last one is the one that the current administration makes, is that controlling greenhouse gas emissions would destroy the economy, which of course is ridiculous. The issue of the time and space scales is another major problem in policy making. Climate change varies geographically. It's greater over land than over the ocean. It's greater over higher latitudes than lower latitudes. The impacts and vulnerability to climate change vary geographically. The long time lags in many climate change processes means future generations will have to deal with the consequences. And human-induced climate change can't be mitigated rapidly or easily. It requires reducing the net global emissions of long-lived greenhouse gas emissions to zero. It's going to persist for centuries, and even if we stabilize CO2 at its current level, the climate will continue to change for decades to centuries because there's already unrealized warming in the climate system. And this figure illustrates the magnitude of the problem. Now, there's 5 things plotted in this figure. This bottom one is the CO2 emissions. This is the CO2 concentration resulting from those emissions. This is the predicted global temperature from the CO2 forcing caused by this concentration. This is the sea level rise due to thermal expansion of the ocean caused by the warming. And this is the sea level rise due to ice melting from the warming of the planet. Now you can see in the CO2 emissions, we're still on the rising limb of that curve. We haven't reached the maximum yet. We haven't peaked our emissions. It's still rising. So sometime within the century, if we are able globally to reach a peak in emissions and then start a decline, CO2 levels in the atmosphere would continue to rise long after the CO2 peaks, because we won't have reduced emissions enough to reach a net zero global greenhouse gas emissions. So CO2 will continue to rise. Now, in response to that forcing from the CO2, the climate will continue to warm for decades to centuries. It will not be stabilized, even though eventually we will stabilize the CO2. There will be unrealized warming in the climate system because of the forcing from the CO2 already in the climate system. And of course, the oceans will rise because of thermal expansion of the ocean water because of the increase in temperature. Most of the heat is going into the ocean, not the atmosphere. And of course, sea level will rise even more because of melting of glaciers and land ice. Now, the diversity of emission sources is another major problem in coming up with a coherent policy to reduce emissions. You can see here the electricity production, the heat production, accounts for about 25% of the global emissions of CO2 alone. Agriculture and forestry and other land use changes, another 24%. 6% from buildings, 14% from transportation sector, 20%, roughly 20% from industry, and another 10% from other energy sources. So somehow you've got to reduce the emissions from all these sources in order to stabilize the concentration of greenhouse gases. Now we have essentially limited options on what to do about this. Mitigation, reduce the emissions or enhance the sinks. Now we've looked at ways to reduce the emissions, change essentially the way we do business with respect to a lot of the economic activities in this world. Enhancing greenhouse gases sinks is another way of doing it. Land use changes that enhance the uptake of carbon, fertilizing the ocean with iron to increase the absorption of CO2 by the ocean, removing CO2 directly from the atmosphere. These are all being considered, but it doesn't seem likely that they alone will ever solve this problem. Adaptation. Reduce the adverse consequences, prevent the adverse consequences on natural and managed ecosystems, on infrastructure, etc. We are facing inevitable climate changes, and adaptation is something we've got to pay more attention to. We've got to do a lot more work on adaptation. Geoengineer the climate system. Essentially intervene in the climate system by changing, for example, the albedo of the Earth by emitting sulfate aerosols into the stratosphere to increase the reflection of sunlight energy before it ever enters the climate system. So this is one option that's being considered, but as I'll say in a minute, it doesn't seem like it's the option of least likely to be taken. And of course, the final option is just continue business as usual, do nothing, and hope we can live with the consequences. So some mitigation and adaptation is already going on, but there's a lot more needed. We clearly need more R&D on strategies also, a lot more than we're doing now. Mitigation alone isn't enough because the climate is already changing, and it can't be stopped quickly. Adaptation alone won't work because it gets costlier and less effective as climate change grows. Minimizing the amount of adverse effects can only be achieved by doing a lot of mitigation and a lot of adaptation. That's the world we're facing. So what we need to do is enough mitigation to avoid the unmanageable and enough adaptation to manage the unavoidable. That's put simply, that's what we need to do. Now, geoengineering, as I said, geoengineering is the least viable option because it poses poorly understood risks. The amount required to offset enhanced warming would escalate for millennia, generating greater risk if it was ever terminated for any reason. So while we have to consider it if it looks like we're facing catastrophic changes, as an option, this seems like the least viable option. So I don't think we're going to invest a lot in this. I don't think we should invest a lot in this. I think there's the other way, mitigation and adaptation is the best way to go. And of course, geoengineering would not mitigate ocean acidification because if we're going to geoengineer the climate, we're going to continue to emit CO2, and that's going to cause even increasing acidification. So here are the mitigation realities we face. CO2 is the biggest piece of the problem. It accounts for most of the radiative forcing, and 80% of it comes from burning coal, oil, gas, and gasoline and natural gas. Most of the rest comes from deforestation and burning in tropical forests. The industrialized and developing countries are now about equal in terms of their total CO2 emissions. Global energy systems can't be changed quickly. There's almost $15 trillion invested in global energy systems today, and the turnover of those systems is almost 40 years. So we just can't tear them down, stop using them today, and hope that we can replace them immediately with another energy source. So how much mitigation and adaptation or how much mitigation do we need? Now, this is the UN Framework Convention on Climate Change. The Paris Climate Accord is the second attempt at an international effort. It was signed by 196 countries, including the US, and established three goals. I'm going to include here two. The third goal deals with setting aside money to help countries adapt. The first goal is to hold global warming to well below 2 degrees centigrade, with efforts to limit it to 1.5 degrees centigrade. This is, don't allow the global average temperature to increase more than 1.5 to 2 degrees centigrade. And to aim for global emissions to peak as soon as possible and achieve net zero emissions in the second half of this century. Now this is a large goal to realize. Reaching this goal would require rapid transitions in land use, energy, industry, buildings, transport, and cities. The global net human CO2 emissions would need to fall by 45% from 2010 levels by 2030, reaching net zero emissions by 2050. And any remaining emissions would need to be balanced by removing CO2 directly from the atmosphere. And right now, we don't have the technology to scale up to remove CO2 directly from the atmosphere at the scale required. Now, it's possible to do this within the laws of chemistry and physics, but doing so would require unprecedented changes. I mean, huge changes if we're going to do this. Now, this is the allowable CO2 emission curves to stabilize global atmosphere at a 2 degree or less rise relative to the pre-industrial state for different climate sensitivities. Climate sensitivity is what the global average temperature increase would be if we increase the concentration of CO2 twice the pre-industrial level. So if the climate sensitivity was 1.5 degrees centigrade, we could still emit more CO2 to the atmosphere, and then so that it peaks around 2050 and then a fairly rapid decline. If the sensitivity was 2 degrees centigrade, we can still emit some, but the peak has to occur earlier, and then we have to decline the emissions. If it's 3 degrees centigrade, we're already too late. We are too late to keep the global average temperature from going above 2 degrees centigrade. So here's what the science says. We're already too late. So we better get busy with adaptation. But we shouldn't stop at mitigation because, if it goes to 2, we don't want it to go to 2.5 or to 3. So let's get moving with mitigation as well as adaptation. So in closing, I'll just go through these challenges. The failure to reduce greenhouse gas emissions has essentially caused us to be where we are today. We need to prepare for inevitable and potentially abrupt changes in climate. We've got to do more adaptation to even greater climate change in the future. Every year we continue our reliance on fossil fuels means adaptation will become more difficult, more disruptive, and more expensive and ultimately less effective. We need to look at a mix of technological changes in our energy sources. We need to increase the efficiency of energy production and use. We need to look harder at carbon capture and storage this will likely be necessary to do, but right now we can't do it at the scale that's required. We have the technology to do it, but we have never scaled up to the level at which it's going to be required. We've got to do more R&D to develop new energy technologies and lower the economic cost and improve the performance of existing technologies. We need to rapidly accelerate the transition to a low-carbon economy and a low-carbon world without dislocations that are likely to beset us. And the countervailing view assumes politicians will do what is needed before the window comes crashing down on us. This is what we're facing. Whether you like it or not, this is the world we're facing. And why politicians can't grasp this or refuse to grasp this, I mean, we know why, because they have short-term thinking and they think only about what the immediate cost is going to be to them and their constituents and to the people that support them. And we've got to change that mindset. I mean, we're all in this together, whether we like it or not. I mean, we're all contributors in one sense or not to this problem. I mean, I drive a car that is more energy efficient than the one I bought before. I'm looking to buy an electric car. But we've got to look at our lifestyle and think about what we do in our daily lives. And we've got to put more pressure on politicians, the people we elect to public office, at the local level, at the state level, at the national level, and force them to think about this in terms of this long-term problem. This isn't going to be solved with short-term solutions. They've got to think long-term about this, and they've got to confront the reality that only long-term solutions are going to solve this problem. The science will continue to provide more evidence of this problem, but the science isn't going to change the fundamental problem at all. Science will improve ways to solve the problem, provide new technologies to help us solve the problem, but the fundamental science about climate change, the risks, the consequences that we face is not going to change as far as I can see. So with that, I'll take questions. Thanks.
Thanks, Jerry. I'm sure there are questions for that sobering topic.
Two questions. One is, I didn't really hear much about economic incentives as a driver to begin these conversations, and just what is your perspective on the use of economic tools to begin to move the needle?
Yeah. Well, clearly, economic incentives need to be an important part of the solution. I mean, when industries look at their costs of changing the way they do business, if you can't provide them an economic incentive to do that, they're very likely to change. I don't have any particular economic incentives in mind, but I think when you look at the arguments for not doing anything or doing so little, by and large, they come down to economics. People think they're going to lose their competitive advantage. I mean, the Trump administration argues that we shouldn't do anything because we're going to lose our competitive global advantage economically if we're forced to reduce our emissions more than other countries. Well, we have a moral responsibility to reduce ours more than other countries. But we can do this in a way that doesn't put us at a competitive disadvantage. But we don't think about that in that frame. When industries think about this all the time, how to gain a competitive advantage. If they change their business plans to think about creating new jobs by changing the technologies that they're investing in, the technologies they're building, they can gain a competitive advantage. But they don't think about it in that frame. And so we've got to change this mindset in this country to get away from this sort of monetary cost-benefit analysis and think about, what the problem is, how to solve the problem, and how to do it in an economically efficient way that doesn't sacrifice jobs, cause economic dislocations to any great degree. Yes.
Thank you so much for this talk. This is actually maybe a good follow-up to Eric's question. So a takeaway that I have is that we need to act quickly, but that also this is very complex, thinking about what policies to move forward on. And I'm wondering what your thoughts are on policy frameworks that are intersectional. So like the Green New Deal, thinking about climate as a problem linked to other global challenges, gender inequality,
Yeah.
labor.
Yeah.
You could say a little bit
Yeah.
about how you think
Yeah.
about those.
Yeah, I mean, I like the way the Green New Deal was framed in terms of a target to get to net zero emissions within a limited time frame, create jobs, enhance the economy. That's the right kind of language. So it isn't just like, just another bunch of tree huggers trying to destroy the economy. Put it in a broader economic framework. But you can already hear the scare tactics. We're going to have to stop eating beef because cows produce methane. That argument. These ridiculous arguments. We've got to get away from that. So I think framing it in a larger economic context with the problem, the economy, the jobs, the economic stability, sustainability, all that kind of language has to permeate the discussion about the climate issue. And I think it's useful to do that. And I hope that when you talk to people about that, you can frame it in a broader context. Yes.
Dr. Elwood, the Union of Concerned Scientists last year commissioned a study of 63,000 scientific experts across 16 federal agencies. And this is a bit dated, but they found that about 20% of respondents reported to being asked to omit the phrase climate change from their work, and another 20% of respondents reported engaging in self-censorship. Now, it's been a few years since you've been I guess, retired from the federal government. But what's your sense? Are you talking to federal colleagues who are still employed? What's your sense?
Yeah, I do have colleagues that are still working for the federal government, and they have essentially relayed similar concerns, similar things that are happening in the federal agencies. When I worked for the federal government, I didn't experience, well, during the Bush administration, there were certain words that they didn't want you to use. Mitigation was a word that you should not use in the climate change, anything dealing with climate change. The view then was, we don't know enough to say whether climate is changing, and if it is, what's causing it. So don't talk about mitigation until we've answered those two questions. So anytime you use the word mitigation, it was struck out of any documents that the Global Change Research Program produced. That's changed because we now know that climate is changing and humans are the cause of it. So now we are having conversations about mitigation. But I never experienced self-censorship. I mean, it's troubling to me that, in agencies that fund research, there's words you cannot use. If you're describing something that's factually correct with language that's consistent with the English language, why shouldn't you say it? So, I just think that's really troubling to me, and I hope this changes soon. I hope it changes by the next election, if not before. So that's all I'll say. Yes.
I am wondering if you've heard of the Roosevelt Conservation Caucus, bicameral caucus formed by conservation issues, and also if you look at their July launch of the press conference, there's a lot of talk about climate change in that. There's also the very new Climate Solutions Caucus of two are in the Senate, formed with Republican Mike Braun from Indiana and Democrat Chris Coons from Delaware. Chris actually co-sponsored with Jeff Flake in last year the Energy Innovation and Carbon Dividend Act of 2018, and that was also introduced in the House as well. And that is a carbon fee and dividend type policy.
Yeah.
And in the House, it was reintroduced in 2019 in January, and now has 67 co-sponsors, and the sponsors Ted Deutsch from Florida and Francis Rooney, a Republican from Florida. Everybody else is Democrat. So I was wondering if you've heard some of these, that there is rumblings. There's the Climate Solutions, the Climate Leadership Council, which is primarily GOP oriented, doing a carbon fee and dividend policy that's less robust than the Energy Innovation Act. But have you heard about any of these initiatives?
I've heard a little bit about some of them, not all of them, but I've heard a little about some of them. The carbon dividend idea, I think, is a good idea, but you know, I mean, if it's effective at getting people to reduce their emissions, it's a step in the right direction. So, you know, a lot of these small incremental steps will continually add up and make a difference. But them alone aren't going to be enough, I don't think. I mean, we've got to have a larger effort at a larger scale than these sort of carbon dividend approaches. But economically, it makes a lot of sense, and I think it's moving in the right direction.
Along that, what do you think would be an appropriate scale, like what cost of CO2 per ton?
Oh,
For instance, that one starts at 15, it goes up with inflation and by $10 a year, plus adds $5 a ton
Yeah.
for years that we're not reaching the target set by the IPCC.
yeah, I haven't looked in detail at the analysis of the different carbon fees to see what the trade-off is of different fees. So I don't know. I can't answer your question.
Could you comment a little bit on energy policy? Because the energy policy we have in place has been largely influenced by specific industries.
Yeah.
It's fairly uneven
Yeah.
in terms of tax credits. And I suspect this contributes significantly to the climate
Yeah,
policy.
it does. Yeah. Yeah, it's, Lee mentions energy policy essentially sort of letting things move the way industry wants them to move. And that's basically it. The fundamental issue is we don't have a national energy policy in this country. We don't have one at all. And it's shameful that we don't, given that, we need to define an energy policy that attacks this problem. This is largely an energy problem. It's an energy and waste management problem. That's all human-caused climate change is: energy and waste management. And that's the simplest, in the simplest language, that's exactly how to frame this problem. I mean, our energy technologies basically drive greenhouse gas emissions. Not completely, but largely. They account for a huge fraction of the total greenhouse gas emissions. Not just electricity production, transportation, agriculture. I mean, think about how much energy or how much greenhouse gases we emit for every calorie of food we produce in this country. It's not trivial. So, I think if this country doesn't develop a national energy plan, a national energy strategy to transform away from carbon-based fuels, we won't get there. If we just allow industries to sort of dictate our energy policy, we're not going to get there. There's got to be some top-down pressure. There's got to be economic incentives. There's got to be pressure from the public. The private sector has to buy into this. They've got to become part of the solution, not just the problem.
So Dr. Elwood, it seems like you've been working a little bit on that bottom-up pressure. It looks like you have some fairly public squabbles with this guy named Ed Berry up in the Flathead. And I'm wondering if you could speak specifically to how you would maybe sit down with him and have a conversation where you might not be able to change his heart or his mind, but at least you keep having that conversation. Like, you guys tussle publicly on the pages of those papers up there.
We do, yes. Well, if we can't come to reach some common ground on some simple facts, I don't know how I'm ever gonna, have much of a conversation with him. I mean, there's things he believes that just defy me. They're just demonstrably false things that he believes. And, for example, he doesn't believe CO2 is an important greenhouse gas. Well, physics alone tells us that it is an important greenhouse gas. If you take all the CO2 out of the atmosphere, we have done the experiment experimentally with models. You remove CO2 from the atmosphere, our planet's going to be covered with ice pole to pole. And the simple physical calculations tells you that. Now, he claims to be an atmospheric physicist, and he always touts, that people who believe in climate change don't understand physics. Well, if anybody doesn't understand physics, it's Ed Berry. So, he's published a paper recently in a journal. It's I don't know what kind of a journal it is, but I looked at the paper, I read the paper, and I submitted comments to the journal along with a friend of mine, recommending that the paper be retracted. It is so full of errors that it's just unbelievable. For example, he uses data on carbon-14 in the atmosphere from the weapons testing of nuclear weapons. And he traces the decline in the delta C14, which is the ratio of ratios of carbon-14 to carbon-12 in the atmosphere, divided by the ratio of carbon-14 to carbon-12 in a carbon-14 standard. And he plots that and fits a negative exponential function to it and calls that the E-folding time of atmospheric CO2. Well, of course, that's not the E-folding time of atmospheric CO2, because it's not the rate of uptake of CO2 from the atmosphere at all. It's the decline in the ratio. And the ratio is affected by carbon-12 entering the atmosphere from fossil fuels. If you add anything to that ratio that increases the C12 in the atmosphere, you reduce the ratio. Well, he thinks that that's the uptake of CO2 from the atmosphere. Well, it's not. But that's in his paper. And he claims it was peer-reviewed. Well, anybody who knows anything about isotope geochemistry and the carbon cycle knows that he's wrong. But it's in the scientific literature now. So, if you get asked to review papers, review them based on your parts that are based on your expertise. But if there's parts that you don't know about, tell the editor, you're not qualified to review this part of the manuscript. Here's somebody who is. Send the paper to this person or to these people. I looked at the editorial board of this journal. There's not a single member of their editorial board that knows anything about climate or about the carbon cycle. Not a single member.
What is the journal?
It's the International Journal of Oceanic and Atmospheric Science.
Is it a fake journal or a pay-to-play journal?
It's
that we see
you got to pay to have your pay. Yeah, it's pay to play.
So it's not necessarily.
Yeah.
So one last question, yeah, Tom.
Yeah, well, first for most of you, don't know that I've known Jerry for about 20 years probably, back from Washington, D.C. And I'm listening to him about this talk in the Copernican dialogue with Ed Berry or whoever it is. And I can say as somebody who was younger than Jerry, but not done calling you old. But coming
Thank
up
you.
from D.C., we looked up at people like Jerry who really spoke for the science. They spoke about truth and facts and about dialogue and opportunity to really discuss things in an adult and hopefully a mature way. But, Jerry, I just have to ask you, after all those years back in DC, was there ever a moment back there in the whole climate situation where there was just a moment or a person that you met that you said, here's the opportunity? After watching all your slides about how politicians are obstacles and people are obstacles, was there ever a moment where you thought we really had an opportunity to make a real big breakthrough in the policy realm?
Well, Al Gore was somebody who got it. I mean, he understood the problem. He articulated the problem. He was never in a position to make the difference. I don't think he had the influence in the Clinton administration that he would like to have had. I think if he was president, he would have made a difference. And there are other people in agencies that I admired that I thought were articulate spokesmen and understood the problem very well and were proponents of doing more. People like Bob Carell and the National Science Foundation is a good example. But there are others. I won't mention any other names, but the federal agencies are full of a lot of very good people. They're dedicated to their work. They want to do what's right, and politicians come and go, and when you're working in the federal government, you're at the whims of the powers in office at the time. And you get people in agencies that change the priorities of federal agencies. And, when I was in DOE, we had a director of the Office of Science that never asked for a briefing during his entire years there on our climate programs. Not once. It was almost like he wasn't interested.
Sounds familiar.
And he's now works in the Trump administration. Thank you.
Jerry, thank you very much.
You're welcome.
That was really a good message. What we all needed.
How to grapple with it policy-wise, and we have not had a global